Hello all and welcome to this project on dog breed prediction. In this project, we will see how to use Keras and TensorFlow to build and train and test a convolutional neural network. This convolutional neural network that we will create will be capable of identifying the breed of a dog which is supplied to it as an image. Convolutional neural networks are generally used for image classification. This problem is also a multi-class classification problem, which is a supervised learning problem. For this project, the steps we will use are, we'll first load the data from Kaggle. So I'll show you how you can connect your Google Colab with Kaggle. After that, we'll load the labels that contains the image ID and the breed. We'll check those breed counts. After that, we'll perform one-hot encodings on label of the data prediction column. We'll load the images, convert them to an array and normalize them. Then we will check the shape and size of the X and Y data and build our network architecture after that. After building the network architecture, we'll split the data and fit it into the model to create an accuracy plot. We'll evaluate the model for accuracy score and finally we'll use this model for prediction. In this project, we will start by downloading the data, creating the model and finding out the predictions using this model. This model can be optimized using different hyperparameters which can be used to tune this model for a higher accuracy. This model can be used to predict different breeds of dogs, which can be further used by different NGOs which are working on saving animals and for educational purposes also. So let's get started. In this project, we will see how to use Keras and TensorFlow to build, train and test a convolutional network which will be capable of identifying the breed of a dog. We will use Google Colab for this project as Google Colab provides high computational power and we require that. Before starting, we need to connect our Kaggle account with this Colab notebook. I'll show you how to do that. First, you need to go to your Kaggle account. In this, you should go to the account section and create new API token. This will download your Kaggle token. So in order to connect our Google Colab with the Kaggle, we need to run this command, that is from Google Colab we'll import files and files.upload and we'll upload that JSON file or this Kaggle key that we have downloaded. In this, let's run this cell and upload our Kaggle key. So our key is uploaded. Now the next step will be to install the Kaggle API. We will use the pip installation for this. And we'll run this command pip install Kaggle. It will install the Kaggle API client. Our Kaggle is installed. So next step would be the Kaggle API expects this file into be a Kaggle folder. So we will move it there by creating a directory by that name. And this file will be uploaded into that folder. Also, we'll have to check some permissions that I have make any warnings they don't. So you will run this command. This is chmod 600 Kaggle JSON. It will avoid any warning on the Kaggle tool startup. So we'll run this. So this step was to set up the Kaggle using Kaggle API. We have run this cell and we have set up our Kaggle API. Now we'll create a new working directory where we will store our data and set that as our current directory. As we are working on a dog breed classification model, we will make a directory named dog dataset and we'll change our current directory to that folder. For this, we are using mkdir command and creating a new folder named dog dataset and changing the directory to that folder. So the next step will be searching the Kaggle for the required dataset. In this, we will be searching for the dog breed ID from competition It will search the Kaggle datasets in competitions and download the list of a dataset. As you can see here, it's matching the string dog breed from competition in Kaggle competitions and will give us a list of the available datasets. So as we can see here, this is the dog breed ID from competitions, 691 MB of data, and its download count is 12. So this is the required data. We will download this data using the Kaggle datasets download. For this, we will choose this path. This is the path that we need to set for downloading this data. As you can see here, the data is being downloaded. Okay, so our data has been downloaded into our Google Colab. So the next step will be unzipping this downloaded data and removing any unusable file. So in this data, we will see that we need to unzip this dog data. We'll unzip it and we'll find out that we need to remove that zip file because now it's of no use, and also the sample submission file, which is a by default file provided by Kaggle. We also don't need that, so we'll remove these files and we'll unzip the dog dataset. Let's run this cell and do this. So our data is getting unzipped. Now that our data is prepared, let's start building our model. So in order to start building the model, we first need to import some required libraries. We are building a convolutional neural network, so we'll import some required libraries for that. Like we'll import some layers like dense, dropout, flatten layer, conv 2D layer, max pool 2D layer. We'll use all these layers in creating the model, creating the network architecture. We will be using a sequential model, so we will import that from keras.models. We will train test split our data using the sklearn model selection, train test split. We will also binarize our data using the label binarize function from sklearn process. We will use image function also, which is imported from keras.preprocess, and all the basic libraries like numpy for mathematical computations, pandas for data frame operations, and matplotlib for visualization. We have also imported an optimizer named Adam from the keras.optimize. Let's run this cell and import all our required libraries. So we have imported our required library. Now let's move forward. After loading the required libraries, the next step would be loading the labels data into the data frame, and we will view it. So here we can see that there are around 10,222 rows and 2 columns. The column name is ID and breed. So let's visualize the number of each breed, that is the value count of each breed. So here we can see that different breeds like Scottish Deerhound, it contains 126, Maltese Dog, it contains 117, and so on. So the total number in each class can be found out using the value counts function. As the dataset is pretty large and due to less computation power, what we'll do is we'll select only 3 breeds for this classification. So here you can see that I have made a new list as class names, and I'll pass only 3 classes of dogs here. You can consider more of these classes as per your system's computational power. Let's run this cell and select only the required classes. So we have labeled our data according to the classes of the dogs we have selected. We'll work on only 3 classes, that is Scottish Deerhound, Maltese Dog, and Bernese Mountain Dog. So this data is a classification dataset. So we need to one-hot encode the target value, that is the classes of the dogs. After that, we'll read all these images and convert them into a numpy array because we need to normalize them. So this is the X data. We are creating a numpy matrix with zeros in it. Similarly, we have one-hot encoded the Y data using the label binarize function. Next step would be reading and converting the images to the numpy and normalizing it. So as image pixels ranges from 0 to 255, so in order to normalize an image, we divide that image pixels by 255. As you can see here, we're dividing the image pixels by 255. After that, we'll print the train image shape and the one-hot encoded output shape. Let's run the cell and do the required operations. So here we can see that train images shape is 357, that is the total number of images, and the size is 224 by 224 by 3. 3 is the channel, that is RGB in this case, because these are the colored images, and this is the size of these images. Similarly, the one-hot encoded output shape will be 357 as the total number of images, and 3 because we are considering only 3 classes. Now next we will see how we can build the model for it. So as we are using CNN, we will take layers such as convolutional 2D layers, max pooling 2D layers, as well as flatten. Then we'll apply the dense layers and then the final layer. So let's go through these one by one. So we're taking the model as sequential. As you can see here, we are building a sequential model. For this sequential model, we have taken the first layer as a conv 2D layer. We have set the number of filters as 64. You can play around the number of filters, number of kernel size, activation functions, because it can hamper the accuracy of this model, and you can play around with to get a higher accuracy. This is called the hyperparameter tuning. I have set it according to me. You can change it according to yours. So in the first layer, we need to pass the input shape also. So here we know that the input shape is 224 by 224 by 3. After that, I have applied a max pooling layer and with a pool size of 2 by 2. So what a max pooling layer does, it finds out the most dominant feature in a 2 by 2 matrix. Similarly, after that, I have applied a conv 2D layer again, then a max pooling layer, then again a conv 2D layer, then a max pooling layer. Similarly, you can add as many number of layers that you want if it gets you a higher accuracy. After completing the convolutional layers or the max pooling layers, we will flatten this data because now we need to apply the dense layers. We'll flatten this layer, this data by adding a flattening layer. Next, we will add dense layers. So we are adding a dense layer with 128 neurons, activation function ReLU, and a regularizer, which is of L2 class. Similarly, I am adding one more dense layer, which is of 64 neurons, activation function ReLU, and kernel regularizer equal to L2. The final layer will contain the number of neurons as the total number of classes, which is 3 here. Also, it is a multi-class classification function. So the activation function for the last layer or the output layer should be softmax, because softmax gives us the probability of classes. So in a multi-class classification problem, we generally take softmax as the activation function for the last layer. After creating this architecture, now let's compile this model. As we are working with image dataset, so we'll take the loss as categorical cross entropy. We can also take the loss as the sparse categorical cross entropy, but not in this case because the data is not that sparse. It is used when the data is diverse. Like if we have 10, 20, 30 classes, then we will use sparse categorical cross entropy. We are using an optimizer Adam with a learning data of 0.0001. And the metrics I have taken is the accuracy. Now let's print the summary of this model. So once again, what we have done here, we have used different types of layer according to their features, like conv 2D, max pooling 2D, and flattening layers, and the dense layers. After that, we have compiled the model using the loss, which is categorical cross entropy, optimizers, and metrics. Now we are printing the summary of this model. Now let's run this cell to print out the summary of this model. So here you can see the summary of this model. So we know that the model is sequential. The first layer is a conv 2D layer, then input shape of 220 by 220 by 64, which equates to 4864 params. Similarly, you can see that the max pooling layer, then the conv 2D second layer, then the max pooling second layer, then conv 2D third layer, and so on. After the flatten layer, we have applied the dense layer, then second dense layer, and the third and the final output layer, which has 3, because we are working on only 3 classes. After finding out the summary of this model, this network architecture, we found out that the total parameters, as you can see here, and the trainable ones are 162,619, that are 1,62,619 parameters. So the next step would be to split the data into training and testing, and to split that data into training and validation dataset. So here we are using the train test split function from sklearn and splitting our data. So let's run this cell and split our data into test and train, and then further into validation data. Next, we will fit our model. So in order to fit our model, we'll need to define the number of epochs. Here I have taken 100 epochs. It is a model which requires a very high computational power. So 100 epochs will take around 5 to 6 hours to run. Similarly, I have taken batch size as 128, and I have fitted this model and saved that fitness into history. So here you can see that while fitting the model, what all I have called the xtrain function, xtrain data, the ytrain data, batch size equal to batch size I have defined above, number of epochs as I have defined above the 100, and the validation data which we have splitted above. Now we will train this model on 100 epochs and a batch size of 128. You can try using more number of epochs to achieve a higher accuracy. Also, you can see during each epoch how the model is performing. So now let's run this and see how much time it will take. You need to be very patient about it because it will take a lot of time. As you can see here, each epoch will take around, let's see how much time it takes. So each epoch is taking around 17 seconds. So 17 into plus 17 is 34 seconds. First epoch has taken 34 seconds. Similarly, all these epochs will run. It will take some time. You have to be very patient. Here you can see that it is also printing the loss, the accuracy, the validation loss, and the validation accuracy. So we will see after some time when these epochs will be finished. Then we will again continue with the further steps. So it took me around 1.5 hours to run 100 epochs on this data. You can change this 100 epochs to as much as you want. And let me show you a trick how you can change this time period, how you can increase this computational power of your Google Colab. You just need to get into the edit section, go to the notebook settings, and you can change your hardware accelerator here. You can select it to TPU, GPU, anything that you want, and you can increase the power of this Google Colab. We have run this model and we can see that the final accuracy you are getting is the accuracy of 97, while validation accuracy of 0.75. Next thing we will see is we will plot a graph. We will analyze the accuracy and the validation accuracy according to each epoch. For that I have used PLT, that is the matplotlib.pyplot, and we have saved the history of the model in the history function. I am calling that here with accuracy and the validation accuracy. The title of the graph will be model accuracy. Y level will show the accuracy. X level will show the epochs. Similarly, the legends will be train and val. Let's run this and analyze how the model has learned with each epoch. So here you can see how the model has learned with each epoch. The red line shows the training accuracy while the blue line shows the validation accuracy. The next step would be predicting using the predict function and evaluating the model. We'll use the predict function to make predictions, and using this model we'll also find the accuracy on the test set. Let's do this. So we get an accuracy of 83.33. As I've told you earlier, you can work on this accuracy by hyperparameter tuning your model. You can tune your model in order to get a higher accuracy. You can change the number of layers, the kernel size, the number of neurons in the dense layer. Similarly, activation functions, optimizers, initializers. So here you can see that we get an accuracy of 83.33. If you change your model hyperparameters, you can get a higher accuracy, but you have to be very patient about it because it will take time and you have to run the model again and again using different hyperparameters. Next, let us see how we can plot the images to compare, and we'll also find the max value from prediction list and comparing the original value versus the predicted values. For this, I'm using that same plt.imshow, plotting an image from the X-test. So this was the image I printed. Originally it was marked as Maltese dog, and we have predicted it correctly. It has shown that it is a Maltese dog. So our prediction is accurate. You can see the original image. So next I will show you how you can use this model to create a Streamlit app. Streamlit allows you to create standalone application, ML based and deep learning based application. So for that we need to save this model. So we'll run this command model.save, and we will save this model as dogbreed.h5. So h5 is the format for saving a model. Let's run this cell and save this model. So model is saved. We can check it here. Here you can see that our model is saved. We will download this model. We have downloaded the model. So let's go to the project folder where I have saved this. So here you can see that I have stored our model dogbreed.h5. I have created a requirements file here and a main app which is stored in a .py format. I'll show you how I created this main app and how to get this requirement app. I have already requirement text. I have already shown you how you can download this model using the model.save. I have stored all these in a single folder which is named as dogbreed. So now let us see how I created this main app using Streamlit. As this is a .py file, we will create it in a code editor. I am using Atom here. You can use any code editor that you want, such as Node++, Sublime Text, etc. Let's see how to create this app. So here you can see that I opened that app I have created in the name of main app.py. So initially I have imported all the required libraries, such as NumPy for mathematical computation, Streamlit for designing the front end and all the functions that Streamlit has. We'll use CV2 to convert our images into OpenCV, and to load the model that we have already saved, we will use keras.models, from which we will import load model. So in order to start our app, the first step that we should take is to load the model that we have already created. So in order to load the model, I have used this function load model and load our model dogbreed.h5 into a model named variable. So what this command will do, it will save our model into this model variable. Next, I have taken a list of class names. As you already know that we were working on only 3 classes of dogs, and they were Scottish Deerhound, Maltese dog and Bernese Mountain Dog. So I have taken these dog names and stored them into a class, into a list which is named as class name. So next I will show you how you can use different functions that are there in Streamlit. So the first thing is st.title. So the title function allows you to set the title of an app. So as you know, the title should be in bold and in a large font size, so it will take care of that. So we have set our title as dog breed prediction. Other than that, I have set a markdown using st.markdown. We can also say that the subtitle. In this subtitle, I have used upload an image of the dog. So here we will take an image from the user, which should be a dog image, and we will tell which dog it is. So in order to take the image from the user, we will use a function which is known as file uploader. It is defined under Streamlit. So here I have taken a variable named dog image, and in this variable I am storing the image that the user will provide to us through file uploader. A message will be displayed as this: choose an image, and the type will also be displayed, which is PNG here. You can change it to JPEG or anything that you want. It should be an image file for this model, and it will get stored into the dog image variable. Similarly, we'll create a button after that named as predict, and the click of this button will be stored in submit variable. Now we will create the conditions which will run our model and give us prediction. So for that, I've used an if statement. So if submit means if we click the submit button, then it will check if the dog image is not none. So if the dog image is not none, then it will convert the file to an OpenCV image. It will take the image that the user has uploaded, as you can show here, the dog image, read it and convert it into a NumPy array, and convert that NumPy array into an OpenCV image using cv2.imdecode function. After that, we will display that image using st.image function. Up till now, we have seen different uses of Streamlit functions like st.fileuploader, st.button, st.title. You can explore many more that are there defined in the Streamlit documentation. Here I am showing you how to use st.image, which is used to display the image. So we will call st.image and pass the image. Then we'll also pass the channels for this image, that is the BGR, blue, green, red. Now we will resize this image. As our model takes the image size of 224 by 224, so we need to resize the image that a user has provided to us. cv2.resize will take care of that. After that, we will change the shape into 4 dimension because the predict function takes the image size into 4 dimensions. So we'll change it to 1 by 224 by 224 by 3. Similarly, after this, we will make our prediction. We will use the model that we have loaded and we'll predict using the image that we have got from the user. And we'll save this prediction into Vipred. And in the end, using the st.title function, we are displaying the class name, which is the dog breed, as the dog breed is, and the prediction after that. So this is how I created this Streamlit app. It is very easy. You can also try different Streamlit functions like I have shown you here. Now let's move forward and see how we can run this app locally on our system. So before running this app, let me show you how you can create this requirements file. So I'll create this again. Let me delete this for now. So in order to create this, you need to open Anaconda prompt. So before opening the CMD, command prompt of Anaconda, let me copy this path where I have stored my project because I will need that. Now we'll go to the Anaconda prompt. So in the Anaconda prompt, you first need to go to that directory. For that, we will paste that path here. We'll first use cd command and then paste that location here. Go into that location. And now you need to run a simple command which is pip reqs, pip requirement. And as soon as you run this command, it will check all the files that are there in this location and what are their dependencies, like what are the required libraries for that. It's running right now and you can see that it has successfully saved the requirements file in the exact same location that we have passed to it. So now let's go to our folder and check whether our requirements file is created or not. So here we can see that the requirement files is created. Now let me show you how you can run this app. For that, we need to open the Anaconda command prompt and first we need to have Streamlit installed on our system. I have already installed Streamlit on my system and let me show you how you can do that. So for that, let's open the Anaconda command prompt. So in Anaconda prompt, in order to install Streamlit, you should run this command as pip install Streamlit. I have already installed it, but let me show you how you do this. You need to press enter and it will show me that requirements are already satisfied in my system because I have already installed it. Now we need to go to that folder where our file is stored. I have already copied the path as I showed you. So I'll type cd and I'll paste the path and go to that particular folder. So after you install Streamlit, you need to run this app using Streamlit run and the name of your app, that is main_app.py. And as we enter this, so it shows that our app is running on this URL, that is localhost 8501. So let's go copy this URL and open it in our browser. Let me show you. So here you can see that I have copied that path and pasted it here and our app is running perfectly. This is the title as I've already shown you there, st.title, dog breed prediction. This is the markdown that we have set. This is the alt text for choosing an image. Let's browse our files and choose an image and let's see if it predicts or not. So I've already stored a file named doggy in my downloads. Let's open that image. It should be in a PNG format as I have chosen the PNG file. Now let's click on predict and see if it predicts accurately or not. So here we can see that the dog breed is Bernese Mountain Dog. Similar image I have shown you in the Google Colab, and the dog breed there was Bernese Mountain Dog. So our app is working perfectly. So you can see that how easily we created this app. You can also create this app very easily using different Streamlit functions. I hope you understand it properly. Thank you.